Parsa, welcome back. We're on episode 3 of the Learning Health System podcast.
From an informatician's perspective.
From an informatician's perspective. Parsa wants the title to be longer and I want it to be shorter. We'll arm wrestle about it forever.
I just want to be precise.
The scariest thing that happens is, can you show what you just showed me before?
Oh, my gifts from my son?
Yeah, basically, if I don't control myself, I'm going to get beaten up.
Apparently, I need a little bit more violence in my life.
So from your two most peace-loving friends, we have episode 3 of Learning Health System podcasts for informaticians. In our last episode, we covered the entire maturity model. We spent an enormous amount on levels 1 and levels 2, and at one point, Parsa and I broke down and was like, oh my God, we're only at level 1 and we have all of these things in it. My big question for you this episode, Parsa, is how does this actually manifest itself in real life for a researcher in an academic medical center?
Yeah, I think the notion of real-world evidence generation using data from EHR and observational health data to ask and answer really robust clinical trials was not new. There are tools. No. There are actually networks of researchers like Odyssey, which I'll let you figure out what the acronym stands for. It's observational health data and DataScience and informatics combined. So there are people, hundreds of people and institutions that are already doing it, but there aren't examples of tools that does it in a way that concentrated on learning health system approach, meaning allowing a health system, an academic medical center, or a network of partnering systems to be able to use these tools within their own infrastructure, within their own culture, compliance and regulatory environment, within their own data ecosystem. I mean, the EPIC implementation famously is different in every health system.
Let's pick on Odyssey. I mean, as you said, there's Odyssey, there's I2B2, there are others, but let's pick on Odyssey because Odyssey focuses on OMOP, and increasingly OMOP has become actually the international standard, certainly the standard domestically for research data. Odyssey has a tool called Atlas, and why can't people just take this open source tool out of the box, use it? What's it missing from a learning health system perspective? What's it missing?
So let's first praise Atlas. Atlas is a great tool. As I said, people have put a lot of innovation and hard work to inject systematic study designs, cohort-based study frameworks, harmonization and ontology frameworks that allows consistent data representation analytics. It is not really designed to answer a health system level question. It is designed to allow people to interact and collaborate in a network of independent health systems that want to collaborate using de-identified data. Because of that, they have no regard to compliance and regulatory, because from their perspective, everything is de-identified to the level that doesn't even require an IRB. 90% of research inside the health system requires an IRB. So there's massive regulatory perspective and protection perspective that is absent from Atlas, which basically immediately eliminates that as an option or as a serious option to be used by researchers internally in a health system. Technically speaking, as a data scientist, you would like to incorporate clinical text, notes, natural language processing as part of your cohort studies within a real-world evidence generation framework. And that's all absent in Atlas. By design, philosophically speaking, again, Atlas considers everything a public resource. All data is public, all cohorts, all concepts designed by the community belongs to the community and is open. In a health system, everything is private unless somebody decides to make it public.
But I know that a way that a lot of institutions get around this is when they stand up the Odyssey stack, they create two sets of data, one de-identified for external use and one fully identified for internal use. Does that solve the problem?
No, it actually acknowledges a problem. That
I guess it does. It's true.
The universe, at least it is a dual universe. At least we think there is like more than two. Identified data and de-identified data. Atlas doesn't have a way of recognizing that, so you need to have two sets of data sets, one for each. But it doesn't resolve any of the other things like user level access, privacy, connotation. None. It just allows you to build a cohort based on identified data or de-identified data.
So we've established that Atlas doesn't...
It's a great tool, but it's not sufficient.
And one of the reasons is that its inability to hold identifiable data securely. When you're trying to build a tool for a learning health system, what other things do you need to change, or maybe what other differentiators are there between an internal tool that's needed and that Atlas provides?
For the very first thing that you need to do is to find a way to cater a single source data set, one copy of the data in varieties of formats, fully de-identified, which passes statistical or safe harbor criteria for fully de-identified data sets, limited de-identified format, de-identified format, fully identified format. All of these formats needs to be available for researchers just in time using a single source of data. You should not replicate data sets with these different criterias because they're not maintainable, they're expensive, you can't harmonize across them, and you need to be able to traverse between them. If someone came in and said, you gave me a de-identified data set, now I need to identify them because there are patients that I need to contact, or they're in harm's way, or we can help them, or for varieties of reasons, you may need to re-identify. You should be able to traverse between these data sets easily, just in time. So there's just dealing with identification, or what I call identity resolution, in an accountable way. Once you have that, you have to match that with the users, with the investigations and investigators. You need to be able to recognize a public space for analytics, which is available to everyone that has any right to access data. Team-based analytics spaces, which is just a certain group of people that have access to certain part of the data for certain reason. And user level access, because you want to provide access, monitor, audit, and scale access becomes relevant. So that's what, again, we have done through search. We have created these processes that comply with whatever the protocols are that the team of users and the single user has access to, which means we have a way of recognizing the protocols, data use agreements, IRB, which is the institutional review process for human research subjects, which allows us to determine what data is allowable to be accessed by who, for how long, for what purpose, and not only audit and track and make sure that that's what is happening, but also enforce it. So the moment a contract runs out, or an IRB runs out, or a member of an IRB leaves the team, their access to data sets that were linked to that project are also revoked. A lot of time in a healthcare system, cohorts or the kind of people that we are doing research are not identifiable by a research tool. They may not fit a specific cohort criteria or inclusion-exclusion criteria. For example, if a clinician wants to study their own patients, a set of patients that they've been following up for years, they're interested in them, and they have a registry in RedCap or in an Excel sheet somewhere. Shouldn't they be able to link those patients to their clinical data from everywhere?
There's no way to do that in Atlas?
No, because there's no interoperability in Atlas with other research informatics platforms inside the health system. So we have built this, you can think about it as an integration framework that makes our version of Atlas, we call it Search, integrated part of our data ecosystem. It is linked with our PACS. It is linked to our biorepository, with our clinical trial management system, RedCap, EMR, you name it. Wherever patients are, we can bring those patients inside this tool, connect those patients with multimodal data sets, and maybe even their clinical text. You want to review their pathology notes. How do you do that? There's no way to do that in Atlas. You should be able to use patients' notes. More than 70% of all relevant documentation of care is in clinical notes. How do you create a cohort study platform that also incorporates all of the varieties of notes? In Montefiore, we do have more than 150 different types.
And Atlas doesn't have a way to store all of these notes?
Well, storing is aside. Storing goes to OMAP, if at all. Using that information within a cohort definition workflow, cohort extraction workflow is completely absent. So
the big advances that you've made at Montefiore are A, they have access to the data themselves. B, they have access to cohorts that they can upload themselves. C, they can go through notes. D, they can download cohorts.
They can, downloading not just the cohorts. Our search allows you to extract data that is directly relevant to your study design by basically downloading your design and making it a data basket for you. So you get all of the data elements that you need to basically set up your study environment in a way that you can ask and answer exactly the questions that you're trying to ask and answer, which is documented in your protocol. And we have 3 different ways of giving you data. You can use our wide or columnar format, which essentially allows 1 row per patient. Every patient is just 1 row in that data set. And if you have looked into 200, 300 variables, you have 200, 300 columns in that data set. It's a pivot table that we automatically generate, which is directly uploadable to SPSS, SAS, Stata, and you can use. If you are a data scientist, you may need entity attribute value format, EAV format, which is this very long data set that every variable is a row. And then there are these departmental needs or large-scale projects that require a registry of their own. It's not for one single user or small use cases. It is a department that is trying to build a registry of prostate cancer patients and follow them up for 5 years. These are data registries or data marts. So we create these mini marts. They're all OMAP based, automatically constructed. You just define your cohort. You say, this is my cohort, either external cohort that you've linked or internal cohort that you have defined and you've generated within our cohort environment. You schedule update rate, and you get those mini-marts in a secure data enclave that is centrally managed, secured, audited. Everything that I just talked about is audited, by the way.
That's probably the last big differentiator, I would think, is the auditability. That it,
auditability to the degree that not only we can tell who is using data under what protocol and for what purpose at all times, and we can audit and track it. We log all of these utilizations in a way that if a patient of ours calls Montefiore and asks, who is using my data? What data of mine have been used by who? How many times and why? Who said yes to use that? We can answer that question. It also allows us to offer a patient-centered consent for our patients that says, these are the kinds of uses that we foresee to have for your data, and these are the data that we are collecting from you. You tell us what research types you want or you don't want for your data to be used in, and we guarantee you that we are going to accommodate that. That level of transparency and patient empowerment is now possible to be done. And because architecturally, that's how we designed it, right? We designed search and all of this infrastructure after the ethos of LearningHealthSystem. And patient empowerment and transparency is a big part of that. Therefore, there are architectural implications that we have also accommodated.
So I'm looking at my notes over here. Is there anything else that we're missing?
Yeah, there are two elements: data quality, massive commitment in data quality, and our ontology services, vocabulary management services. We generate two sets of data quality. One from the general, we call it the express data quality, which basically gives you an idea about the overall shape of the data and the completeness and the consistency of the data that you're receiving for your cohort at this time that you are extracting the data. And you can see if this little variable that only you are using, is it getting updated? Is it has it changed over time, and so forth. And then we give also a comprehensive data quality, which really goes into very deep analysis of every single data point that you are using on the community of the patients that you are interested in, and looks into the temporal trends. Has it changed over time? Is the data as good as it was 6 years ago when you started this, or it has changed shape? You can see everything. These are fit for use analytics that are provided automatically every single time that we give data sets through the system to anyone.
Every time someone runs a report, there's a data quality report that comes out with it that shows them the quality.
Shows them what the data looks like for their study now and how it has changed over time.
And the last thing that I think we want to talk about is vocabulary.
Yes, we manage the vocabularies. Part of it is about data quality and mapping and making sure that some of the concepts that are not present in OMAP but are being used inside our health system, managing that evolving world, which moves in a much faster pace than your standards world. It requires knowledge management and proper mapping and reconciliation after your standard catches up, right?
Yeah.
That ontology management is a robust process that needs to exist if you want to continue using these things at scale that we've done. But probably the biggest contribution that we have is to add a lens into ontology management, which is not exclusively from collaboration and OMOPs or Odysseys externally facing use cases, right? Our users in the health system know about all of the flow sheets and data points and clarity tables and how those tests are named and called inside our health system. Very few of them may know some things about RX norm and LOINC and ICDs. Maybe 0.003% of them know about OMOP concepts. In reality, right? Sure. In reality.
You're talking about clinicians here, yeah, sure.
Clinicians,
much more used to dealing with system, billing codes, ICD-10s, etc.
ICD-10 codes, or exactly the names that they have seen in the Epic, right? Yeah. This is what the CBC is called, yeah. Or hemoglobin A1C is called and they're like in White Plains Hospital, it's called this way. In Weiler, it's called this way. In Moses, it's called this other way. And they know exactly what they are.
Yep.
They use it daily for patient care, for their own internal reporting. They have zero idea about how OMOP, what is the OMOP concept for that.
Yeah.
So creating and casting an image of the data internally that aligns with our users' experience daily with the data constructs and data systems that they know well, and they can trace and track data perfectly in that universe, and keeping the mapping consistent in the backend, transparently presented, as I mentioned, show all of the 333 different versions of the world to users because that's what they know, but only use one OMOP concept that the community cares about when the time comes for those kinds of queries, and be able to adopt both worlds just in time based on what the use cases are, is what we have enabled through this robust extension to knowledge management frameworks that are present. We actually developed a tool for it. We call it Nowana. It is still work in progress. We have great ideas about what it should be. You can imagine that it is adopting the best practices in ontology management and knowledge management, but it is an enabling and differentiating aspect of our technology, which is also why we call our data management environment a semantic data lake and not just a data lake, because it is driven by these ontological lenses that gives multiple perspectives of the world as it's appropriate for a learning health system.
I love that. That's actually a beautiful place to sort of wrap it up and end our little episode, I think, because, episode 1, that's where we began.
Yeah.
Why did these things all start? And they started because of, the need for a semantic ontology.